Assalamualaikum warahmatullahi wabarakatuh. Okay, so I want to continue the topic 2 in part B. Okay, so we look at the conveyance. Okay, 2.3 conveyance after we learn the topic on uniform flow in open channel, that we know about the determination to get the Q, to get the velocity using Chesi formula and also Manning formula. Okay, and also use the formula from the topic 1. Okay, so conveyance is conveyance K. Okay, conveyance K of a channel section is a measure of a carrying capacity of the channel section per unit longitudinal slope. Okay, it is directly proportionally to discharge Q. Okay, so we know that Chesi formula, we use the C coefficient of Chesi coefficient to get the Q is equal to C times by A times by R power of 1 over 2 and S naught power of 1 over 2. So this is the Q is equal to AV. Okay, V is C, R, and so on. Okay, so to get the velocity, so we use the formula from the previous slides on part A. Okay, so in conveyance K, so the value of C A R is we call the conveyance K. Okay, the part of this one. Okay, so the Manning formula Q, okay, is 1 over N, A R 2 over 3, power of 2 over 3, and S naught power of 1 over 2. So the K 1 over N A R 2 over 3 is the K, the value of K. Okay, this is the pointer of K. Okay, this is called the conveyance K. Actually is okay, this one. Okay. 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 The CAR, this is the K. Okay, so this is the conveyance K or channel section measure by of the carrying capacity of the channel section per unit longitudinal slope. It is directly proportionate to discharge Q. So this is called the conveyance K. Okay. So the section factor Z. Okay. 2.3 is conveyance factor K. So in section factor is we call the section factor Z. Okay. In the Manning formula is AR2 over 3. Okay. AR power of 2 over 3, which is a function of the depth of formula. Okay. So AR power of 2 over 3 is Manning. Okay. So we get using the section factor using AR2 over 3 from these equations. Okay, so we just do using this equation to this equation. Okay, so this is called A R power of 2 over 3 based on Q over S naught over 1 over 2. So this is called the section factor. Okay, the section factor R2 over 3 is normally used to compute the normal depth. Okay, so using this section factor, so we want to determine the normal depth. Okay, when the discharge Q, bottom slope S0 and Manning roughness and coefficients are provided. Okay, so when discharge is given, bottom slope S0 is given, Manning roughness and coefficient is given, so you can find the normal depth Y0. Okay, computation of Y0 should be through either direct trial and error computation based on graph or through provide design chart. Okay, so to find the normal depth, so they have three methods. Okay, to get the normal depth, so we use the three method. Okay, direct, trial and error based on graph and provide design chart. So if in your test or in your final ask you to state or list three methods to get normal depth, so you can mention this one: direct trial and error method based on graph and provide design chart. So these three method is compute to get normal depth. Why not? Okay, so look at the activity 2.9. Okay, they give you a trapezoidal channel, okay, 5 meter wide, 5 meter wide, and having a side slope of 1.5 horizontal over 1 vertical is laid on a slope of 0.00035. Okay, the roughness coefficient n, so the n is given 0.015. So find the normal depth. So they just give you to get the normal depth for a discharge of 20 meter cube per second. So they give you the discharge. Okay, so given all the parameter here, okay, B, Z 1.5, S0 slope, bed slope 0.0035, and Q. Okay, so you use the equations for trapezoidal. A is equal to by time, okay, plus Z y squared. Okay, you just put all the value because we don't know we want to find the normal depth, because that's why we don't know what is the value of y. Okay, actually y is for find the normal depth here. Okay, so the p b plus 2y is what, this is the formula that is given in table in topic 1. So you use this one, let's put the value here, but we don't know the y. Okay, so this is we using the trial and error. Okay, so R is equal to A over P, so you just put here. Okay, so we get the equation here. Okay, using this one because we want to find the normal depth here. Okay, so just in terms of y, because we don't know the y is the normal depth here. Okay, so use the many equations using the section factor z. Okay, using this many equation. Okay, use the many equation and you just pull out and just just fill into this. At the left side, AR over 2 over 3, power of 2 over 3, and at the right side here, KQN divided by S0, power of 1.5. Okay, so we get the so just put all the value here and this one. So we just put the area, the area we get from the previous slide, in terms of y0, in terms of y0, because y is, we don't know, we want to find the y0 here because we want to find the y0 normal depth. So y0 here, AR, we use the R here and power of 2 over 3, and we know that put the N here and put the S0 here. Okay, and you calculate. Okay, so you get the calculate here. Okay, but we don't know the y naught. Okay, so we have this formula here, calculation using this formula. So we using the direct trial and by trial and error method. Okay, so you just put this here. Okay, just put in this column, why not in the first column here, and this, okay, this value to the second column here. Okay, so you just try and error, just put the first, you assume that y naught is 1. Okay, so if y naught is 1, so you put to this calculation, to this formula, so you get the value of this one is 5.391. okay, and you put the second row, you assume that y naught is 2. Okay, so you get the value of this one. Okay, it's not the same as this value. Okay, so you just assume y naught is 1 point, because this is bigger than this one, this equation, this value, so you just put, okay, just less from the 2, you get 1.8. okay, so you insert to y naught is 1.8, so you get the value of this one is 15. So but this one is 16. Okay, so you just more than 1.8, so you just put 1.82. okay, so you just assume that, or you can assume that 1.9. so if you put 1.9, so you try to calculate, so you get what's value when the y naught is 1.9. okay, but when we get the when we assume that 1.82, so we get the value is 16.035. okay, so that's it. The value is near as this value. Okay, so we stop at this stage. Okay, we stop at this stage. So we find that y naught is 1.82 meter. Okay, so when we use the trial and error, so we use this method. Okay, just assume first y naught is 0, 1. So you get what value in this row. Okay, and until you get the value is equal, okay, equal with the value here. Okay, so you just stop at this part and you get the y naught. Okay, so this is by trial and error. Okay, so using the graphically, so you use the same, okay, you same the equation that you find from the calculation that you get. Okay, so use the same this formula here. Okay, so using the graphically, okay, you also use the table here, assume the y, okay, and you find the value here, assume 1 to 1.5, 1.7, 1.8, 1.9, and 2 here. Okay, so you get the value here, and then you draw the graph. Okay, okay, so when you use draw the graph here, graph from this, okay, y naught, you just sketch the y naught at this, okay, at this axis y naught, and this formula is AR2 over 3 power, this is at this axis. Okay, so you get this. Okay, this is at y axis, this is for x axis, so you just draw the graph. Okay, sketch the graph here, so you get this line here, the graph line here is from this table. Okay, okay, you draw this graph from this table. Okay, so and you just get, because you get this value here, okay, use this value and state at this graph. Okay, you get 16.036. okay, just draw the one line here until you stop at this line and you get the line x, y axis. So you get the value of y axis here is, you get the y naught is y 1.82. Okay, so this is using the graphically method. Okay, so in your test or in your final, that will mention you to get the normal depth, whether you use the try and error or graphical method or graph method, or they either use the chart method. Okay, so you use which one of that three method. Okay, if in your final or in your test is not mentioned which method that you will use, so you can use try and error. Okay, you can use also the graphically, or you can use the chart method. Okay, so for the most the semester that all my student, I will ask that to use the try and error. Okay, if it's not mentioned which method that you must use. Okay, if in the question asks you to use the try and error, so you use the try and error. If use the graphical, so you must use the graphical method and draw the graph. Okay, so that's all. So if not mentioned, so you can use that three method. You can choose one of that three method. Okay, so look at the design chart. Okay, so this design chart is given. Okay, if this chart is given in your test or in your final, so you must use this chart. Okay, so from the AR over 2 over 3, AR or B, so you get at this axis. Okay, this x-axis is for this value. So and the y-axis is the y over b value or y over d. Okay, actually y over d is for the circle. Okay, for the circle. Okay, this type of channel using the circle here. Okay, and AR using the B, bottom way is we use the rectangular and also the rectangular. Okay, rectangular and the Z, if the rectangular and the triangular also on, with the Z is 1.5, Z.2, 2.5 and until to 4. So you use the which line here. Okay, this line is for rectangular. Okay, and this line for the trapezoidal here. Okay, so the Z is for the rectangular. Okay, because the rectangular have no Z. Okay, only the triangular and the trapezoidal have the value of Z. So you use the value of Z here, the line here, Z 2.2, 1.5 to 2.5 and 0.5. So this is to find the types of trapezoidal and triangular. Okay, so when we get the, okay, assume that the B, we get the 0.2194. Okay, so and with the Z, because the previous questions is Z is 1.5. Okay, so you just use the AR over power of 2 over 3 and divide by B, so you get the value of this one. Okay, you use this one and you get the value of this one. Okay, you just calculate. So you just draw the line here until to the Z 1.5 is at this. Okay, at this line here. Okay, at this line. Okay, this line here. So and you just draw the okay, at the line blue here. Okay, the line below here is Z is equal to 1.5. So you just draw the line for here, line for get the Y. Okay, Y over B. So at this part, you get Y over B. Okay. Okay. If Y over B, you get 0.35. Easy you get. Okay. So you get 0.37. Okay, actually 0.37 is y over b. Okay, so you just add the x-axis. So look at the x-axis. Okay, you just divide by, you get the value of 0.2194. Okay, actually, okay, you get this one. Okay, okay, intersection at z is 0.5. You get the channel given y over b is 0.37. Okay, you get at the y-axis, you get 0.37 is y over b. So just times by b is 5, so you get the y naught is 1.85. Okay, so this you get the real value for y naught using the design chart. Okay, so you can use between these three methods. Okay, so whether you can use the trial and error, you use the graphical method, and also use the design chart, so you can find the y naught. Okay, so y naught, just remember that y naught, to get the y naught, so you use three method, only three method to get the normal depth: trial and error, graphical method, design chart method. Okay, that's all to find the normal depth. Okay, so this is design chart for line open drain for urban stormwater. So this is the JPS, okay, Department of Irrigation and Drainage use, okay, the design to the drain, okay, to design the drain, open line drain, okay, the trapezoidal, okay, and the triangular. So this is the use guideline, okay, the design chart that they use, okay. So look at an activity 2.8. So they give you a concrete line trapezoidal. So this mention the trapezoidal here with n 0.015 is to have side slope of 1 horizontal to 1 vertical. So 1 horizontal, 1 vertical. So z, that means z is 1. Okay, so the bottom slope is to be 0.0004. Find the bottom width of the channel necessary to carry 100 meter cube per second of discharge at a normal depth of 2.5 meter. Okay, so given y naught is 2.5. Okay, so it's given 2.5 here, normal depth. Okay, so the z is 1, s naught is 0.0004 is the bottom slope, n is 0.015, and the q is 100. So they want to find the, okay, bottom width to get the b. Okay, find the bottom width, okay, to get the value of b, okay, of the channel. So first you must use the value of formula of area of the trapezoidal. So in terms of b, because you want to find the b here, okay, and also the p is formula is in terms of b, and the r is also in terms of b. Okay, so use the many equation as a function of section factor. So you use this equation. Okay, first you must use this equation, okay, to find the parameter that you want to find. Okay, so you just put all the value that a and the r, okay, in terms of b here. Okay, so you get the value here is 75. Okay, so in terms of b, so you can also use by trial and error. Okay, so if you use by a trial and error, okay, so you just draw the table here. Okay, as you want to find the y naught. Okay, so you also can use the trial and error to find the bottom width. Okay, so you just add this column. So you just mention b, assume, okay, assume what value for the b1. Okay, so as you assume that s1, so at this part, so this value of this, okay, you just put to this column here. Okay, so you just find the value here if B is 1. Okay, so if you get the B is 2, so what is the value here? Okay, so if you get the value of, okay, so you just try and error. Okay, you first find using the try and error until you get the B is this, until you get the B is 6, maybe 60. Okay, maybe this you get the 15 and 16. Okay, and then you get the 15.33 until you get the value here. Okay, it's the same as this 75 here. Okay, until you get the same value at this value. Okay, so you can do the method using the try and error to find the B. Okay, so activity 2.11, so you see using also try and error method, find the normal depth. Okay, so this is to find the normal depth. Okay, first step, so you must know the area. Okay, second step, you must the perimeter, and third step, you must know the R. Okay, so to find that normal depth or bottom width, so you must have Q, you must have B, S naught, and N. Okay, so to use the Manning equation section Z factor. Okay, so use this one. So you use this equations. Okay, put all the value to this one until you get the value of 2.167. So you use try and error until you get the, okay, so you just put also the table here. Okay, so just remember that if in your final or in your test one, if using try and error, so you must draw this table. Okay, you must do this table to put this is y naught. Okay, this is y naught over 3 y naught 3 plus y naught here 2 over 3. Okay, so you put this in part of this row. Okay, so this is y naught. So you just mention that maybe you just put 1. Okay, you get the value here. Okay, if you get the 2 here, maybe you get it, but the 2 is more than, maybe you get the value of more than 2. Okay, that's why. So after you get the 2, so you just put to the 0 2 to 1.9. Okay, so you get what? Okay, until you get 1.942. Okay, until you get the value in this part here. Okay, is same as this value. Okay, okay, so that's why. So in try and error, in case of using try and error, you must draw this table. Okay, must draw this table. Okay, so look at this activity example. So also, but this is sewer pipe using the circle, semicircle. So a sewer pipe of 2 meter diameter is laid on a slope of 0.004 width and 0.014. Find the depth of flow. So to find the depth of flow, okay, to find the y naught here, depth of flow is y naught. Okay, when the discharge is 2 meter cube per second. Okay, so all the, okay, use the area of this sewer pipe. Okay, use the area, but using the Manning equation. Okay, you must always use the Manning equations. Okay, section Z. Okay, so put all the value to this Manning equations, and you get the AR 2 over 3. Okay, so you can find here. Okay, AR over T. Okay, and use, so this is use the design chart. Okay, because in these questions not mentioned which method that you use. Okay, if in questions and the design chart is given, so you must use the design chart. Okay, but if not mentioned, so you can use try and error, or you can also use the graphical method, and also you can use the design chart. Okay, so in this case, activity 2.12, maybe they give you the design chart. Okay, so let's use the design chart here. Okay, just calculate the design chart. Okay, and you get AR over D 8/3. So you just look at the y over d. So look at the design chart here. Okay, so you just calculate the value of this one. Okay, until you get the 0.2205, and just look at the circular. Okay, the circular is at this line. Okay, this blue line circular, and put the value there. So you get the value of 6, 0.6. Okay, 0.6 is y over d naught. Okay, so y is equal to 0.6 times by d naught. So you get the value of y. Okay, so this is using the design chart. Okay, if in case in your final or in your test is not mentioned in the questions that which method that you will use. Okay, so but you must look at the behind your question. Maybe at the list of formula, they also attach the design chart. Maybe that's you must use that design chart to find the y from design chart. Okay, so if in your question is not mentioned which which method that you will use, so you must look at the back of your questions. Maybe they attach the design chart or the table. Okay, so you can or attach with the graph paper. Okay, so if attached with the graph paper, so you must use graphically graph. You must draw the graph. Okay, using the method of graph. Okay, so if attach the design chart, so you must calculate from the design chart. Okay, so look at the simplification for white rectangular. So this is white rectangular channel. White, okay, maksudnya lebar, dia lebih lebar. So simplification for white rectangular. So this mean mention for white. Okay, white channel is mean that y naught over b is less than 0.02. Okay, for white channel is y naught over b is small, therefore r is equal to y naught. Okay, so for white rectangular channel, that simply that r is equal to y naught. Okay, so just remember that if the white rectangular channel, so the r is equal to y naught. Okay, so normally it's used only in rectangular channel. Okay, not in trapezoidal, not in triangular, or in circle. So only use white rectangular channel. Rectangular channel. Okay, normally use. Okay, discharge per unit weight. So Q is Q over B, bottom weight. This is the symbol of Q. This is small q. Okay, so this small q is called discharge per unit weight. This big Q is discharge. Okay, just remember that Q is unit in meter cube. Okay, B is M. Okay, so the discharge per unit weight. That's why meter cube per second, meter cube per second per meter. That's mean for the per unit weight, discharge per unit weight. Okay, so look at activity 2.13. So water flows through a vary. Okay, vary. So you must look at you must understand the text. Okay, text in this question. Okay, flows through a very wide channel. Okay, if mention very wide channel, automatically they use the rectangular channel. Okay, So very wide channels, they use the rectangular channel at a rate of 2.5 meter cube per second. The channel has a base width of 60 meter, channel slope of 0.005 and bending coefficient of 0.013. What is normal depth? So this is to find the normal depth. Okay, find the normal depth but using the very wide channel. Okay, so very wide channel, so you mention that you use the rectangular channel. Okay, this is using the rectangular channel. This is B to find the Y node here. Okay, so if we use the very wide channel, so we know that R is equal to Y node. Okay, this is simplification for very wide channel in rectangular channel. Okay, so for a wide rectangular channel, R is equal to Y. Okay, or R is equal to Y naught because we want to find the Y naught. Okay, so many equations use the Q is equal to Y naught over V. Okay, so this is only for, so just remember that this only for rectangular channel. Okay, only for rectangular channel. What rectangular channel? Okay, so use this equation here. Okay, use this equation only for wide rectangular channel. Okay, so use this equation because Q is equal to Q over B. Okay, you just method using the Manning, put the Manning equation to this Q. So until you get the I N over R, this is for the Q and also the B. B is also this one, so you get the in this part here. Okay, so that's why R, because we know that R is changed to the Y here, so that's why you change to the Y here. Okay, and we know that Q is Q over B. Okay, so we get the value of this one. Okay, so no need to worry, actually for this equation is also given. Okay, this also given in your test or in your final in the list of formula. So just put all the value here, so until you get the Y naught. Okay, 0.6272 meter. Okay, so this is more easy because this using the direct question because they use very wide channel, so you just use the many equation. Okay, but many equation you must change to the discharge per unit width. This is only for rectangular wide channel. Okay, to get the normal depth. Okay, so we change to the new topic of base hydraulic section. Okay, so new topic 2.5 base hydraulic section, most effective section. Okay, a non-erodible channel should be designed for the base hydraulic channel efficiency. Okay, so the base hydraulic channel. Okay, so the base hydraulic section give minimum area for a given discharge. So we just refer it to the channel convenience. So we using the channel convenience K is 1 over N AR power of 2 over 3 here. So it's a constant for the convenience. So simply that Q max, R max, maximum, Q maximum, R maximum, and P minimum give best hydraulic section. So you use these equations and the Q max, R max, and P minimum is for best hydraulic section to find the best hydraulic section. Okay. P minimum reduce construction cost, less lining material, and reduce friction force. Okay, so this table is given. Okay, if in for to find the best hydraulic section. Okay, so the other table that we use in topic 1 is also given. Okay, that's one to find the Y and Y not. Okay, but for the best hydraulic section, so they also to find the Y, but Y for best hydraulic section. Okay, so you can use this. You can use this table equation in this table. Okay, table, this is table best hybridization. Okay, so you just simply use the formula to get the area for trapezoidal, rectangular, semicircle, and so on to find the best hybridization. Okay, so look at the activity 2.14. So what is the best hybridization for a rectangular channel? Okay, for a rectangular channel, we know that A times is equal to B times by Y. Okay, so this is using the equations in topic 1. Okay, this is for rectangular channel. Okay, but for best hybridization, from this equation P here, because best hybridization when the P is max, Q is max, okay, P is minimum, okay, using this basic equation, okay, P is minimum, okay, simply of Q max, R max, and P minimum. So when P minimum, so we must use the dP over dy is 0, okay, because dP is minimum, so dP over dy is 0, okay, using the best hydraulic section here. Okay, dP over dy is 0 because P is minimum, okay, to get the best hydraulic section. Okay, that's why we guess dP over dy is 0, okay. So let's first assume A to be constant here, okay. So P, use the P, A over Y, B is, okay, from this one, okay, you just get the B change to A over Y, okay. So you get the B here, this is P is equal to B plus 2Y, okay. Okay, from this one, P is equal to B plus 2Y. Okay, so A, we just put the B because B in terms of A, because we want to put the B here in terms of A here. Okay, because we want to get all the formula is in terms of Y. Okay, so that's why you put the B here. Okay, you put B to this here, and then you get this. Okay, A over Y here plus 2Y. Okay, because you first assume A to be constant. Okay, because A to be constant in terms of Y. Okay, because you want to get dP over dy is 0. Okay, so you get dP over dy. Okay, you just put the, okay, just relate to your maths. Okay, pembezaan maksudnya pembezaan you kena ni the calculate the dP over dy of this one, so negative ay power of 2 plus 2 here. Okay, because from this, okay, from this one to this. Okay, so you get for base hybridization, so you get mass equal to 0, so that you get the A, okay, from this one, okay, from this one, so you get this, okay, and B Y E is equal to 2YE, okay, you just put back Y, okay, because A to EY, okay, so you get the, okay, from this equation is from the previous, this one, okay, B is equal to AY, okay, B equal to AY here, so you just put the here, and BYE, okay, and you get the B is equal to YE. P, okay, P is B plus 2YE, so you get the P 2YE, okay, B, okay, from the B here, okay, B you put to this one, okay, and you get the YE, and you get the P is equal to 4YE. Okay, this is YE for effective. Okay, actually effective is Y effective. Hydraulic best hydraulic section or most effective section. Okay, that's why we use the YE. Okay, so we get the R over A P. So A for 2YE. Sini A you just put to here and put the P back here to here. So you get the R. Okay, so this is most hydraulic sections in rectangular. Okay, that's all. So this is the how we know that the section is best hydraulic section for rectangular. So you must just change your formula from the normal formula from the topic 1 until you get the best hydraulic section formula. Okay, so you get this one. Okay, so show that the base hydraulic trapezoidal section is 1/2 of a hexagon. Okay, so for a trapezoidal, so we use the normal formula for the trapezoidal. Okay, from the trapezoidal here for base hydraulic section, so you must know that dp over dy is 0. So you just use this A. Let's first assume A and Z to be constant. So you get the from this equation. So you can change to this equation in terms of A and Y here. Okay, because we want to assume that A and Z is to be constant. Okay, in terms of Y. Okay, so from this one, you change to this one. Okay, from this one, change to this one. Okay, so and then substituting B to P. Okay, so you substitute B. After you get the B, okay, put back the B to this one. Okay, so this is 1. Okay, just assume that this is 1, that is 2. Okay, and then you get this as 3. Okay, after you get the formula of the 3, so you put back the 3 formula to 2. Okay, to 2 here. So that's you just substituting to B. P is A. So in terms of that one, so you just dp dy here. Okay, so you get the for best hydraulic section in terms of YE. EYE is for the effective section. Okay, the most effective section. So you get the A is 2 here. So YE here. And P also your P at the first here. You use the P and put back the A to this here. Okay. So just put the A you get here to put here. Okay. So you get the P here. Okay, so therefore R is equal to A over P. So you put back the 2. So you get the R is Y, E, and 2. That's why. So after this one, so you get the R is equal to Y, E over 2. So you get that the trapezoidal is the best hydraulic section from the formula of trapezoidal. Okay, so from trapezoidal, you just change to the best hydraulic section. So until you get the R here. Okay, if Z is allowed to vary, so just put the Z here. Okay, kalau Z tu perlu untuk digunakan, so if Z is allowed to vary A in terms of Z, so you just change the Y. Okay, change the Y to in terms of A and Z. So substitute into P. So you get the value of YE. Okay. So and you get the dP over dz. So you just calculate again as the A. Okay, as the A is a constant. Okay. So this is Z is allowed constant, so the use dp over dz, but A constant, so dy over dp over dy. Okay, so this is dp over dz if the z is allowed. Okay, actually this is final question the previous semester. Okay, so you get the ZE. Okay, so ZE, just put back the value of ZE, so you get the P. Okay, so you get the P, so you put back the normal equation. So the normal equation for the parameter of the trapezoidal, so put back the B and you get the B. Okay, the value. So actually the P, okay, the parameter of best hydrolyzation, because they use the YE. So this is the bottom width of the best hydrolyzation. So you find that. So this parameter that you find to get the best hydrolyzation. Okay, I will explain more in our next class. Okay, so this is just for general explanation. So if you don't understand, so I will discuss more in our class. Okay, so this activity 2.16, also a slightly rough brick line trapezoidal channel carrying a discharge of 25 cube per second is to have a longitudinal slope. Analyze the proportion of efficient trapezoidal. So this is, if we mention efficient, so automatically is to find the most efficient channel for trapezoidal channel. Okay, for this one, efficient of trapezoidal channel and the most efficient channel section of trapezoidal shape. Okay, analyze. So analyze is just derive from the normal formula, okay, to the best hydraulic section formula. Okay, rough brick line give meaning roughness n is 0.017. Okay, so fixed slide slope 1.5 over 1. So we know that the best hydraulic section, okay, for the trapezoidal that we have calculated from the previous slide. So we use that formula, okay, for the best hydraulic section. So we get this one. And also we get the, after you put all the value of Z, okay, so in terms of YE, so you get the area and also R. So from many equations, so use the many equation here, so you use the A here, okay. A, just put to this equation, many equation and the value here, so and you get the Y effectiveness. Okay, so this is to how to find the Y effectiveness in best hydraulic section. Okay, the previous slide at the early part A, we want to the early slide that I mentioned, we want to find the Y naught, okay, using the try and error, graphical method and design chart. Okay, but this is best hydraulic section. We want to find the Y effective, okay, Y effective in best hydraulic section. So because in questions mention about the effective, so when this mention about the effective, says this is more for best hydraulic section. Okay, after you get the YE, so just put back the value of B in terms of YE and put the YE there. So you get the B value. Okay, get the B value and we get just draw back the trapezoidal with the YE here. Okay, this is Y normal here, 2.830. Okay, but you get the, okay, you get the, sorry, one at from this one YE. So this is YE and the B. So this is the new best hydraulic section for trapezoidal. Okay, so this is more complicated. It's okay. If you don't understand, I will explain more in our next online class. Okay, so just, okay, if the side slope is not fixed, so the side slope and other channel characteristic for most efficient trapezoidal sections are ZE. So this is for the Z. Okay, if the Z, so you get the value of Z. Okay, you get the area and R. So for use that area that best hydraulic section. So put to the many equations. So you just get the YE. After you get the YE, put back to that this equation to find, okay, okay, wait to the this one and also this one, so you get the new B, and also the new YE. Okay, so this is for the best hybridization for Z and also for the trapezoidal. Okay, so that's all. So this is a more channel of combined section. Compound section channel that are composed of several distinct subsection, which is subsection difference in roughness from others. Okay, so we use the Q. Okay, VAQ is view A. So this is the total. Okay, that's all. Thank you. So I will give you some tutorial. Is combined between topic 1 and topic 2. Okay, because that topic 1 and topic 2 is always use the same formula, and into same formula, and also to find the value of y naught, the depth, normal depth, and also the best hydraulic section. That's all. Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh. Until we'll meet again in our next class session. Okay, assalamualaikum. Thank you.